We are going to be looking at data structures. We're going to be looking at trees and binary search trees. Now, in computer science, when we talk about trees, it does kind of resemble the actual tree in real life. So you would have a root and then you would have branches coming out called nodes. We're now going to look at the keywords when we talk about a tree in computer science. So root has no parent. So a root is the first one right at the top of our tree. So in this case, it's 1. The parent are anyone that has children. So 1 has children, 2 has children, and 4 has children. Now 3 is not a parent because it has no child. A child is anyone that has parents. So you could say everybody apart from the root would be a child. So 2, 3, 4, 5, 6, 8, 10, and 11. Next, we're going to look at our leaf. Our leaves are nodes with no child, so no children. So 5 and 6 would be a leaf. 8, 10, and 11 are also leaves. Siblings, if we look at siblings, are nodes with the same parent. So in this case, 2, 3, and 4 has the same parent, 1. 5 and 6 are siblings, their parent is 2. And finally, we have 8 and 10 and 11, their parent is 4. Your turn now. Have a go at pausing this video and answer the following questions. When you finish, unpause the video. Now let's see how you get on. How many parents nodes are there? Now we have Emma, Daniel, Olivia, Ava, Lucas, Sophie, and William. So there are 7 parents. How many leaf nodes are there? Our leaf nodes are the ones with no children. So Chloe, Ethan, Mason, Laura, Maya, Loy, Zoe, Noah. So we have 8. Who is the parent of Sophie? Well, Sophie's parent is Olivia. So we would say Olivia. Who is the right child of Lucas? Well, Lucas is here. The right child, looking at the right, is Nora. So Nora is the right child. I hope you got along really well with those 4 questions. Now let's look at the applications of binary tree. We're going to look at HTML specifically. So our web pages are actually created by the DOM, the Document Object Model, and all this is actually a data structure, a tree data structure. Now, although the document doesn't look like it, so when you open a web page, it's like, well, how is that tree structure? But let's take a look at an HTML document. So our HTML document, as you can see, we've got the HTML, and inside we've got the head and the body. Now, the head and the body are the child or the children of HTML. If we look closely at the head, if you look at, let's say, the style is inside the head. So we could say the style is also a child of the head. Now, in the head, you actually have other children, like the title. If you look at the body, H1 is the child of the body. Same with the paragraph. So the P is also the child of the body. So that's an application of data structure for trees. Now let's look at a specific data structure called binary search trees. So this is a binary search trees and it has a very strict rule. In our binary search tree, we can only have 2 nodes. So in this case, 14 is the root and it's got 10 and 28. You cannot have more than 2 children. So you can't have 3, 4 children. You can only have 2 children. You can have no child, you can have 1 child or 2 children, and that is it. So let's look at the rules. So each node has at most 2 children, a left child and a right child. Now there are rules with the left, who is on the left and who is on the right. The left subtree The rule is that the subtree, the left one, must be less than the nodes, the parent. So all the values in the left subtree are less than the value of the actual node. So 14, the numbers on this side are going to be less than 14. So 10, 6, 11 are all less than 14. On the right side, the same rule apply, except you look for the numbers that are greater. So on this side, 28 is greater than 14. And when you look down, 31 is greater than 28. All this number here would be greater than 14. Another rule is that it is applied recursively, so each subtree must have the same rule, so it's consistent. Everybody would be having that same rule, every single node. So the left would be smaller than the parent, the right would be bigger than the parent. We cannot have duplicate, so duplicate is not allowed. So let's say I want to insert 10. Well, 10 is already here, so I can't insert 10. So just be mindful, you cannot have duplicate at all. Now let's have a go at an example of how to draw a binary search tree. So I want to have a binary search tree that has the following nodes: 8, 3, 10, 1, 6, and 14. So the first one is 8, and that is going to be the root. Now number 3 is less than 8, so it's going to go on the left side. Number 10 is bigger than 8, so it's going to go on the right side. The next number is 1. Well, 1 is less than 8, so it's going to the left. 1 is less than 3, so 1 is going to be placed on the left side of 3. Next number is 6. Well, 6 is less than 8, so we go to the left. Well, 6 is bigger than 3, so we're going to go to the right. Last number to do, 14. Well, 14 is bigger than 8, so it's going to go on the right. Well, 14 is bigger than 10, so it needs to go on the right. Your turn now. Have a go at this question. So draw a binary tree for the following numbers: 14, 10, 11, 28, 18, 31, 15, 6, 38, 23, 17, and 32. Pause the video to have a go. Right, let's see how you got on now. So 14, 10, 11, 28, 18, 31, 15, 6, 38, 23, 17, and 32. All right, well done. Now, if you've liked the video, please click the like button. Now, let's do a summary of what we've learned so far. So, a binary search tree, it must be ordered. So that's the rule. It's a very strict rule. The left subtree values must be smaller than the parent. The right subtree values must be bigger than the parent. And the rule applies recursively. So we're going to be calling our function recursively. If I want to insert the number 23, I'll look. Well, 23 is smaller than 25. 23 is bigger than 15. 23 is bigger than 22. So it's going to go on the right side. Now, a binary tree does not have to be ordered. So if the word search is not in that word, then it doesn't have to be ordered. For a binary search tree, the word search, if you see that word in that keyword, then it must be ordered. So most common misconception is if I draw a binary tree, it doesn't have to be ordered. But if it's a binary search tree, it must be ordered. Now see if you can go on to our next video. It's looking at the pseudocode for inserting into a binary search tree using a recursive algorithm. See you soon.